All right, let's start. It's exactly 4, and we're tight on schedule, as I'm told. So I want to make sure next speaker, Aaron, gets enough time. So welcome everyone to a session on what is a verifiable credential and why does it matter. Thank you so much for being here. So my name is Kristina. I work on identity standards team at Microsoft. First, big caveat. This talk is not about WSRC verifiable credentials data model. It's not about JOT verifiable credentials, JOT verifiable presentations, linked data proof verifiable credentials, linked data proof verifiable presentations, all that scary stuff. It's not about that. It's about, well, you'll see. This is where I want to start. How do we normally represent identity? And notice I didn't put digital identity, because I think this is where it starts, right? Our plastic cards in our physical wallet. So I have my driving license, I have my employee card, I have my house insurance, I even have my public transportation card. I have cash and, all that other good stuff in my physical wallet. Well, what is this emerging way to present identity that we keep talking about, that, we can't stop talking about? Isn't it this? Isn't it digital cards in a digital wallet? And a big caveat here too, right? Just like my physical wallet had different things, a digital wallet can also have not just digital cards, collection of attributes, but also, passwords, passkeys, and whatnot. Just a caveat. So let's experience a digital wallet. Why do we keep hearing wallet, wallet, wallet? Why is it so exciting? And let's use an example that we all went through. I'm sure you checked into the hotel when you came here to attend Identiverse, right? And I'm sure at the hotel reception, you were asked to present an identity. So let's use that example. Potentially, out of your physical wallet, you took out your driving license, maybe a passport, you presented it, hotel receptionist took it, checked, and you got your hotel key card. So who is this card issued to? It's issued to me, right? A person who owns both physical card and digital wallet. Who is this card issued by? An authoritative issuer. It's not a driving license issued by, university would not make sense. And these cards are portable. Just like, I'm taking them in and out, I can carry them together with me, and they're multi-use. I don't have to go back to the issuer, potentially Department of Motor Vehicles, every single time that I'm using this credential, right? And I can combine multiple cards. If they want to check where I work for, I can show my employee card alongside this physical, digital driving license. An issuer might or might not know where I'm using the card. If it's a border control, there's hopefully, a log left that I moved from Washington to Colorado. But when I'm using driving license at the bar, there's probably no log. So quite some similarities, right? In this convenient user experience we're so used to. My card issued to me by the issuer I trust. I can carry it around, use it multiple times until it's revoked or expires. I can combine it with other cards, and issuer might or might not know where I'm using it. So some privacy protection, right? So if they're so similar, what are the benefits of these digital cards? You might be asking, well, maybe physical cards are enough, right? So one big element is reducing human error during verification. It's much more expensive to train a human being to verify this card physically. The seal, whether this, this transparency thing is correct or not. It's much easier and faster to install software that can show a green check mark when I present a digital license. Yes, you need to train a user how to use it. Some software costs, but in the end, it's faster and cheaper. And you can unlock new use cases. And this picture is perfect because if you're in front of a laptop, can you stick this physical card inside? Probably not. And again, if your digital card is already sitting on your browser, for example, even faster probably. And last but not least, everything is moving into the phone. Our car keys, house keys, pass keys, credit cards, whatnot. Not everyone potentially using, but it's an undeniable tendency. Well, so maybe why this digital wallet experience is so appealing is because it's so close to this convenient experience you're used to. But how is it different, or is it different from this experience we're used to present identity online? Yes, many of you in the room will tell you there is a federated sign-in, right? And again, let's go back to the use case we used to illustrate the difference. I came to the hotel. I want to check in. If you want to reproduce experience we have with a federated sign-in, how would it look like? In the federated sign-in world, I don't have a credential I can present directly to the hotel, right? So what hotel will do is it redirect me back to the issuer of my driving license. So potentially I have to fly back again to Washington, go to the Department of Motor Vehicles in Washington State, so they can authenticate me. I can tell them I'm okay for them to share that credential with the hotel, and then I fly back to Colorado, and hopefully by the time I get here, Department of Motor Vehicles have already shared directly the data from Washington to the hotel. So just to draw some, differences. And to realize that world where I can directly present this digital card to the hotel, we introduced some new artifacts. So in those cases, there's this issuer-signed card, whereas this authoritative issuer attests that there's a claim about the user. And we can trust it because if you trust that issuer. Well, if we want the user to present, we're introducing this new feature, a user signature, a user-signed card, so that when user is presenting that card directly, the user, by signing over, can prove that that user is an authoritative owner of that credential, of that card. And I've been saying the keyword all over. So there's some similarities, right? The basics, the technical components we use, redirects and whatnot, remains the same. But there's some important differences. And one of them is the role of the user, of this introduction of digital wallet as this new player. In both cases, we still have issuer and verifier, right? Issuer and verifier. In the federated sign-in model, there is a user interaction, user consent and authentication, but it's still through the user agent, right? Where in a digital cards model, we have a user through a digital wallet being an active participant who has the ability to sign over that card and present it. So let's see, how are those new architecture and new artifacts influence the difference? So who are these cards issued to? And you see, in the federated sign, we're going to use issuer-assigned tokens, right? So they're issued direct to the relying party, just like Department of Motor Vehicles in Washington sent the card directly to the hotel. Who are they issued by? Well, in both cases, they're issued by an authoritative issuer, right? So you need an authoritative issuer. So maybe not that self-sovereign. Are they portable? If I want to take my driving license data from Department of Motor Vehicle to another place, there'd be one small issue. An identifier, my identifier, within the Department of Motor Vehicles would be namespaced, would be tied to the context of that Department of Motor Vehicle, right? So if I want to take it to another place, it would not make sense within this new namespace, new environment. But with digital card world, we potentially have an opportunity to have a globally unique identifier. So if attributes are tied to that identifier, I can take that identifier, which can be understood regardless in which namespace or environment you're sitting in. Are these cards multi-use? If I go to another hotel, I don't know, in another city in Colorado, not Denver, that hotel will make me do the same dance all over again. Potentially, I have to go back to Washington, Department of Motor Vehicles again, and give them consent, authenticate, and come back. So those issuer-signed cards in federated sign-in world are one-time use by design. Can I combine multiple cards? Well, technically, when I go back to Department of Motor Vehicles in the Washington state, they can go to my employer, my house insurer, get their data from them, under my consent, of course, and aggregate it and send it to the hotel. But it's not really common, and two, the signature on the issuer-signed thing sent back to the hotel would still have authority of the Department of Motor Vehicles, right? So the nuances are quite different for me being able to send to present cards from multiple issuers in one transaction. Does the issuer know about my usage? When Department of Motor Vehicles sent the data directly to the hotel, it knows that I'm checking into that hotel, right? So yes, by design, in the federated sign-in model, the Department of Motor Vehicles would know. And it's not necessarily bad. This is important, right? Because if I'm an employer, I want to make sure my employees are not stealing the data and taking it to the competitor. I want to make sure my employees are working in a secure environment where they're working from home, right? So federated sign-in model offers an immense value in certain scenarios. And in digital cards, as we have seen, depending on architecture, it depends, right? Whether the issuer would know or not. So there are certain differences. In federated sign-in, the cards are issued directly to the verifier relying party. In both cases, you would need an authoritative issuer. The cards are limited to the namespace of that issuer. The cards are one-time use by design. Can you combine them? Technically, yes. In practice, don't really see it. Issuer knows by design. I'm not saying whether it's good or bad. I'm just pointing out the differences. And where there are differences, it means this new model, which introduced these differences, has the potential to meet new use cases, right? So what are these differences that could be enabled by using these digital cards? So one, attribute level attestation. And identity governance might be a good example, where right now, when I'm an admin when I control access to the resources of my company, I can grant access to those resources only based on the fact that the user works at that one company, so not much rich information. Whereas with a digital cards model, I can potentially request multiple cards, prove me you work there, you have required training, you have this education, whatnot. So kind of a decision-making based on a richer set of data. No account creation use case also becomes possible. An interaction where a verifier, as a user, I want to access a resource. Verifier is asking me to present certain attributes. I send them, verifier makes a decision to give me access to service or not, over there, ends. No account creation. But then you have to find a relying party who's willing to do this flow without an account creation, because usually you would want, from a business perspective, right, an account with the user as a user relationship. So maybe, the smart devices authentication at the edge is one of those use cases. Another thing, scaling across thousands of organizations. This is possible because the flow is independent from the availability of the issuer and because ad hoc trust is possible. What I mean by ad hoc trust is where the request to show a credential comes in, and even if I would not know from whom the request is coming, I can make a decision whether I want to accept that request or not during the runtime, on the fly. That's what I mean by ad hoc trust. Where do we have thousands of organizations? Potentially in supply chain. And because we touched upon the keyword, which is trust, let's dig a bit deeper. And it's the tip of an iceberg, right? And there'll be a lot of great sessions on trust at Identiverse. It's never just technical integration, right? Usually you would have legal agreements and whatnot. And what's really different in the digital cards model is, from an issuer and verifier perspective, I want to know whether this wallet can securely store these credentials without tampering with them, right? Because digital keys become very important. And from a holder perspective, I want to know whether this issuer is actually an authoritative issuer and whether this verifier is going to treat my PII correctly after I present it, right? Not going to reuse it, impersonate me, whatnot. So there are more room for legal agreements than in the traditional model, right? And these can be both this ad hoc trust, which we introduced anew, but it can also be the legal agreements that we're used to. In the federated sign-in model, we do require certain legal agreements between the issuer and the verifier, right? And I'm not downplaying how hard it is to get it right. I'm just saying it's potentially not a new problem, and we can build on the existing expertise to solve it for this digital cards model, where now we have two legs where to have these legal agreements. And last but not the least, this is very important. Another driver for digital cards, public perception. Like real conversation with the government issuer. The governments are saying, we honestly don't care where the citizens are using these cards issued by the government. But the public perception, that the government is going to survey and track is so dominant that we cannot afford having an architecture where verifier talks to the issuer. So this has been a big driver for having this decoupling issuance from presentation of these cards. So by now you should be wondering, well, isn't it this talk about verifiable credentials? And you're right, because we've already met verifiable credentials. The idea of verifiable credentials is to design these components and mechanisms necessary to realize this world of digital cards. And multiple design choices are possible. This is why I started by saying it's not only about diversity receive verifiable credentials data model, right? So we started by saying how conceptually this digital cards model is similar to this physical cards experience we are used to. And then we saw how there are some similarities architecturally with the federated identity model we're so familiar with, but there are important differences which enable these new interactions, new user experience. So what are the caveats we should be aware of, right? And just to tip of an iceberg, this is just data models and credential formats, right? So the MDL, for example, data model meets the requirements and the points we've been checking throughout this presentation, just as well as diversity verifiable credentials data model, right? And just because I got hands-on, this is a real ISO-compliant MDL example, which I find really, really cool. And if we need to redefine the verifiable credentials in this lighter blue box, find a better terminology, let's do it. But all I'm saying, let's look at it as a bigger picture. And as I said, it's only data models and credential formats. When you just enter verifiable credentials, this is probably what you face. Verifiable credentials is just this. Credential formats are just this line, right? You need to figure out entity identifiers. What cryptographic suites are you using? How are you going to revoke it? What are the trust frameworks are you going to use? I think this is where we lose a lot of people. They're like, we don't know what choices to make. Isn't it? How? Right? So the thing is, your use case you're trying to solve does not equal to this humongous world of verifiable credentials of digital cards, right? So what you need to do, you need to find this peaceful place for your use case and where it fits within this larger set of options of verifiable credentials, digital cards. Just a couple of few thoughts what to consider, right? First, scope. Are we talking about enterprise space or consumer space? That's going to greatly influence the relationship of digital cards infrastructure with federated sign-in. As I said, in the enterprise world, federated sign-in brings a lot of value. But in consumer space, there are public pressure, whatnot, different factors. Market. Established market or emerging market. Super important. In the established market, you may want to use established existing libraries. You want to use NIST-approved cryptography. You may want to ensure backwards compatibility because you want scale stability. But in the emerging market, you may want to try new cryptography, zero-knowledge proofs. You may want to turn academic papers into implementations. You may want to not care about backwards compatibility. And it's okay. They're different markets, as long as you don't try to mix them up together and acknowledge they're different. Use cases. Is that high assurance or low assurance use case going to influence your legal agreements decision? Ad hoc trust, if it sounded scary, for high assurances, maybe. But there are lower assurance use cases for digital cards where the ad hoc trust may actually fit in quite well. And of course, whose identity are we talking about? Individual, legal identity, machine, whatnot. So if I interested you well enough, there are a couple of talks to follow up. Tomorrow's a keynote at 8:30 a.m. This is what also we heard at the keynote from Ping this morning, where we'll show an interoperable presentation of verifiable credentials between Ping Identity, Microsoft, and Workday. And quoting someone from EU experts group, openly for verifiable credentials might be one thing we can agree on in the verifiable credential space. So it might be an important talk. So yes, flexibility of verifiable credentials is both exciting, but can also be confusing at times, right? As we have seen with different options. But I think with a bit of imagination and collaboration within the industry, your use case will find the right spot, the cool spot, within this humongous world of verifiable credentials. Thank you. And I have 5 minutes for questions. Yes?
Do you think that verifiable credentials are essential for Web3?
The question is, was a verifiable credential essential for Web3? I think one point is that if you associate Web3 with blockchain, verifiable credentials, did I ever mention the word blockchain in my presentation? I didn't. Did I mention distributed ledger technology? I didn't. So it's not that blockchain is mandatory to realize this word of verifiable credentials. So if you have been scared whenever someone's been pitching verifiable credentials to you that you have to use blockchain, that's not true. But vice versa, using these verifiable credentials in the Web3 world might be beneficial. And what I mean is, the world of verifiable credentials, because you have this user-signed component, it means each user would have a separate key, right? And in the Web3 world, with crypto wallets, people are used to managing those keys by themselves. They know that if they lose that private key, they'll lose a Bitcoin, which is worth, some millions probably. So maybe as a first adoption space, that Web3, for some of the verifiable credential use cases, Web3 might be an interesting place. But again, we have to be clear that we're talking about different market. It's not like, I don't think you'd be able to take these verifiable credentials implementation in Web3 directly into the enterprise world. But it could be an interesting place to start. Yes?
So my question is about revocation.
Yeah.
It seems a very good solution for credentials which are longer lived. But if issue and verify don't talk to each other in real time, how do you think we can implement revocation?
There are multiple ways. Yes. Sorry, the question is, if issuer and verifier are not directly talking to each other, how does the revocation work, right? There are multiple ways to do it. One is old school. You can do issuer call home. You can make verifier talk to the issuer. Again, does not meet the expectations, right? So what mainstream implementation is happening right now is issuer, or something called revocation list, right? But revocation list that is not hosted directly under the issuer. So when the verifier looks up that revocation list using the identifier within the credential, it's just going to say whether if bit is 0, it's not revoked. If bit is 1, is revoked. So you can check whether credential is revoked or not by looking at the thing that without issuer knowing. There are some accumulator-based, more advanced solution, but where I see people settling is this byte map-based solution, byte vector-based solution. Yes? Offline use cases? Yeah, great question. So the question was, how do we do this offline presentation, right? And so one aspect I didn't really mention is scenario-wise, there are two scenarios. One is the same device. When I'm on my phone browsing, I click a zip link, I go to the verifier, they redirect me between application. So that scenario is much easier to implement using offline because it's app-to-app redirect. If you have keys cached to verify, you can actually, everything can happen offline, especially if it's a single, SPA and it's already loaded, you send a credential with a fragment, again, no need to touch the internet, for example, right? In a cross-device flow, it's a bit trickier because so cross-device flow is, I'm on a laptop, I see a QR code, I scan it, the credential have to cross the boundary of two devices, so it's usually HTTP post. So that's where potentially you're trying to redefine an NFC-based protocols, for example, but that's, next action item that we are actively working on.
And forget about the revocation.
And actually, one interesting aspect that comes out with issuance and verifier not talking directly is selective disclosure. Because the reason why we have not really talked about selective disclosure in the federated sign-in model is because it happens real time, right? User consented to certain credentials and claims, attributes, and issuer selectively discloses at real time, right? But that's why when it's decoupled, an issuer for multi-use purposes would have probably pre-issued everything. You would have to have the functionality, right? Any other questions?
Just a comment.
Yeah.
It looks very much
So yes, JOTs are one of the formats how you can express verifiable credentials, and it's probably the one that you would be most familiar with in terms of libraries and whatnot, yes. So there is some active work happening to match the JOTs we are used to the expectations of this world, because as you have seen, you want to add stuff disclosure and whatnot. Yeah, yes?
How do you address theft of the wallet?
Sorry, theft of the wallet?
Theft of the wallet.
Entire wallet?
Or the credential in the wallet.
Right.
There's like a verification.
Well, they're not bearer exactly. So if we go back to this slide, so I sneakily added user's public key here. So issuer is signing over the user's public key. So only the user who controls the private key tied to this public key is being able to present this credential. So it's not bearer. Yeah, it's tied to a certain user, right? And now to your point of recovery, right? What if I lose them? So that's, if everything is stored locally, only locally on the device, yeah, it's gone. But that's why another aspect I didn't mention is this deployment model, where how I presented it, you would assume everything is just stored locally here, right? But high assurance use cases, for example, would require a cloud component, for example, and that's absolutely possible. You're still, so imagine, OS code flow. From a device, I'm sending a code, and then after that, a cloud backend, which is potentially my personal data store, whatnot. From there, it talks to the data exchange itself could be server to server, let's put it that way. So it's in the cloud. So that architecture is also possible to potentially enable recovery, right? When I lose everything, I can get my data that I used to have in the cloud, from the cloud, for example.
Wonderful.
Okay.
Thank you so much, Ms. Joseph. Fantastic.
Thank you, everyone, for coming.